Hi everyone, my name is Thomas Kim. Today is February 4th, 2019. This is my 41st episode about template metaprogramming. In this session, we will learn about matrix chain multiplication in C++, dynamic programming. Please double-click this link to download dynamic matrix library. This session is based on matrix chain multiplication program, dynamic programming by this video.
Hi, the topic is matrix chain multiplication.
This gentleman, Abdul Bari, he explains all the details behind the matrix chain multiplication. Please watch this video to follow this session. This session is based on this video, matrix chain multiplication dynamic programming. Also, show more, download this source code, right click, save link as, save. So we downloaded two files. About the theory behind matrix chain multiplication, please watch this video. More about multidimensional matrix theory and application, please watch these videos. These are my own videos and you can double click these links, then you can learn more about dynamic matrix programming. In the download folder, please unzip this file. Then copy this file, copy, and double click this folder and paste it here. Then go up, rename the folder like this. Matrix chain multiplication. Now copy this folder to your working directory. I paste it here, double click the folder, copy the folder path, then right click your command prompt, properties, paste the folder path starting here, then click OK. Start Visual Studio Code. Go to File, Open Folder, paste the folder path, then enter, select folder. Now open matrix chain, this CPP file. Please note that this is Mr. Abdul Bali's code. This matrix chain CPP is prepared by Mr. Abdul Bali. I found there's a few bugs and I will fix that first. In the command prompt, dir, you should see matrix chain CPP file. We will fix a bug in this file first. This file, G++, std, C++17, matrix chain CPP, or gexe G. Say, please note that the last number is A0. This is bug. I will fix this bug first. Here in this code, I will rearrange this code a little bit like this. Then an indent. I fixed like this. Then the bug comes from here. Okay? The bug comes from here. This actually means, L equals H. Okay? But when this overflows, this can cause the problem here. So I will modify like this. If H means this number 5, plus 1 is less than 5, we have to do like this. Okay, we have to fix like this. Then this is correct. Else, then we copy this code. Then we can just Then we have to do like this. Then with this, let's build once again. G. No, it still cannot fix. In this case, we can just put H. I fixed like this. Also, we don't need this. We can just put H. Let's try it. Okay, the problem is fixed now. So instead of doing this, we can simply put like this. I will fix it once again. Let's try. Okay, it all works. And this is original. Then we modify code like this. And I copy once again. I will now change it to fixed. I will fix it. Copy. Like this. I fixed, changed the name. Also, I will change the name here. Like this. And we need to include string. Include SS stream. And we also need a string. And here we are returning string. std string. Then here, instead of we can merge. Please watch. This is the same block of code. Okay. Instead of doing this, we can merge it like this. Copy this part, cut, and we have to paste after this code line. And if it is not 0, then this is 0. It means else. Okay, it is just else. I fixed it like this. And we don't need this. Now I fixed like this. std o string stream os I modified like this. Then return os string. I modified the code here. And also in this part, os std o string os then it returns a string. In fixed returns a string. Then here os like this. Then here os cross. Then os like this. Then os closing parentheses. Then we return os str. This code actually is identical, and we will fix and run it. Now I have to print out here like this. Cout like this. Then I will build CLS. Voila! It becomes prettier. Please note that this is binary tree coming from this algorithm. We will turn this algorithm into real application. I mean, we will turn this program, this function, into real functioning application that executes matrix multiplication in this order. That's the purpose of this session. Now open this chain demo CPP. I opened this file and I will enable this part and disable this part. Then I will build this chain demo CPP and change the name chain demo CPP. Then G. Please note that this is exactly the same multiplication order that I just shown. If you examine the code, this code is actually the same thing. We are actually allocating. We are really creating matrix 1, 2, 3, 4. 4 matrix. 5 by 4, 4 by 6, 6 by 2, 2 by 7. We create 4 matrix. Then we initialize each element of a matrix. This is matrix vector. We initialize each element of A, this matrix, with random numbers from 0 to 10. Then we process. We use matrix chain product program that we will implement. Then we display the result like this. So the application actually allocates matrix A 5 by 4 like this. These are random numbers. And another matrix 4 by 6 random number. Also this is random number and this is random number. Matrix of random numbers. Then we make multiplication count table and order table. This is M, this is S. Then using this order table, we build this multiplication order. Then we really compute these 4 matrices. Then we display the result. So we are turning this matrix multiplication order into real application. To turn this algorithm into real application, we need to familiarize ourselves with the matrix library. This library, talkplayfun matrix.h. We will learn how to use this matrix library first. Click this link. Create test matrix CPP. In this file, include talkplayfun matrix h int main. First, we define element type of matrix using element t int. We can use double if we want. Define element type of a matrix. Then we define matrix type using matrix t. talkplayfun matrix. We use this element type. We define a matrix with the elements type element t. In this case, element t is defined as int, so this is a matrix of integer. If we change it to double, then it becomes matrix of doubles. Okay, I will use it int. We can change it anytime. Now we define a vector over matrices, okay, like this, using vector over matrices t. This is type. You can also use like this, talk play fun, vector of matrices t. Here we provide this element. So this means a vector over matrices over element type element t. We are defining a vector over integer int matrix. This is type. We define random generator. Random t. We are defining random generator, talk play fun. Random t. We also provide integer element. We are creating random numbers of integer. Define random number generator. So element plays a central role in this application. Now we make an alias. You can say make matrix, or we can say create matrix, whatever. Then talk play fun, make matrix. We need to define integer matrix. So this is, we provide this. This means we are creating integer matrix, and size t is element index type. Okay, we are providing index type. This is function cm for create matrix. Now we define this a vector of matrix like this. This is the type MA, matrix array, like this. CM, create matrix 5 by 4. We are allocating matrix, create matrix 5 by 4 element matrix. Then CM 4 by 6, CM 6 by 2, CM 2 by 7. So we are creating 1, 2, 3, 4 matrix, and we assign to matrix vector of matrix type MA. Or we can just use like this too. I will just do like this. Now we create the random generator. Random t. I say RND or just rand or random. We provide range. We define a random number generator that generates from 0 to 10 inclusive. Then using this random generator, we initialize matrix for auto A. This A is matrix like this. Then A generate. We have to provide this random generator here. Then we display. We will define constant character NL like this. Or I will just copy here, cut. I will paste it here. NL means new line. STD, cout, A, NL, like this. I will also create STD cout like this. Auto C out. SDD, C out. Then here we can say just auto, C out. Now we will build this application. This is in function main, test matrix. Test matrix, CPP. Okay, CLS, G. It creates 1 matrix, 2 matrix, 3 matrix, 4 matrix of this. 5 by 4. I will make more changes here. C out. A is dim. Dim means dimension. Dimension 0. Then A is dim 1. Then like this. This displays dimension of matrix A. Then we build again. Then it shows matrix informations. 5 by 4, 4 by 6, 6 by 2, 2 by 7. If we run it again, the numbers are different because these are created random numbers. Now we use chain multiplication, auto, matrix product, like this, talk, play, fun, matrix, chain product, like this. Then we provide this matrix, MA. Then we print out, you can say just to say C out, MP, we are displaying the result, the result of matrix, MP, NL, like this. Now we build, run it, 1, 2, 3, 4, 4 matrices are multiplied and the result is displayed here. If we want to display more verbose message, then provide here true, like this. Then build again, G. Then we can find more informations. This is matrix, then this is count table, this is order table, and this is matrix operation order, then this is computation result. To check if our computation is correct, we can say MM. MM means just another matrix. I say SM, simple matrix product. Okay, this is simple matrix product, simple matrix product. This is CM. We can say like this, MA 0 times MA 1 times MA 2 times MA 4. This is matrix chain multiplication. This is simple matrix product. The result should be same. C out, SMP, SMP, NL. We should fix into MA like this. Now let's build and run. CLS G. There is some error. Let's see. 0, 1, 2. It should be 3. This MP is calculated using matrix chain product chain multiplication method. and this is simple matrix multiplication. If we compare the results are identical. So this calculation is correct. This function works correctly. I wanted to implement real working this function in this session, but this session becomes too long. Please watch my next video. In next video, we will create matrix chain multiplication. We will modify this algorithm and also this function to create this matrix chain product. This function really calculates the matrix of any dimension. For example, I modify like this. I have to change into CM. This is 1, 2, 3, 4, 5, 6 matrix. Then we can build again. CLS. Now this is 6 matrix. So we have to change like this. MA 4, MA 5. Because this 1, 2, 3, 4, 5, 6 matrix. This is 6 matrix. So the result is the same. Now this calculation becomes much complex. Like this, this is calculation order. So this order is interpreted and calculated properly. This is multiplication count table. This is multiplication order table. If we want to try with Microsoft compiler, CL, EHSC, STD, C++17, test, matrix, CPP, FE, MEXE. Okay, Microsoft compiler works exactly the same as GNU compiler. I will convert this algorithm into real working algorithm like matrix chain product function in my next video. Please watch my next video.